Friday, March 20th. We are on our page 251 that says classify triangles. There are two different ways that this page talks to you about classifying triangles. We can classify triangles either according to their angles, which we've already talked about that before because we've talked about angles and we know there are three types of angles. Same thing with triangles. But we can also classify them according to their sides and if they're equal or not. So we're going to talk about both ways. The first way is according to the angles, and these words should be very familiar to you already. The first one is acute. All of the angles in this triangle measure less than 90 degrees each, so they're all acute angles. The next one is a right triangle. If one angle, just one, if one angle measures 90 degrees, the whole triangle is classified as a right triangle. And then the last type is obtuse. Again, if one angle measures more than 90, so it's laying back like you're in a recliner, so it's going to look like this, okay? If one angle is laying back like that, the whole triangle is obtuse. And those triangles are going to tend to be long and skinny because if you're going to get an angle like that and connect it, it's going to have to be kind of skinny and almost look stretched out. Now, we're going to take that knowledge and we're going to look at 1, 2, 3, and 4, and we're going to do two different things. They ask you to identify the triangle according to its angles, and then they ask you to find the missing angle. So if you're looking at this blue triangle here, and I have kind of a picture of it here. If you're looking at the blue triangle, I know that I see a box in one corner. That box means that that angle is 90 degrees. That means that this triangle is going to be labeled as a right triangle, and you can write that in that line right beside the triangle. Now I have to figure out the missing angle. So I'm going to take what I know, add those together, and subtract it all from 180 degrees. That's the magic number because that is how many degrees there are inside every single triangle. So I know that the box means 90. They give me 40. I put those in my parentheses. I add that up. I put it here. That equals 130. And then I subtract. 180 minus 130 is 50. That's my missing angle. My missing angle is 50. Look at number 2. If the two bottom ones are 60, 60, 60, what do you think the last one is? Yeah, it's going to be 62, but I want you to show me your math there below that is going to be just the same as this one. But if all the angles are the same and they're all less than 90 degrees, that yellow triangle is going to be acute. Correct. Shouldn't say right. You might get confused. It's going to be acute. Correct. So look at 3 and 4, label them first, and then figure out those missing angles. Now let's talk about the other way to label a triangle, which is they're describing to you here in the purple triangle or purple rectangle there. You can label a triangle according to its sides. So the first one, the green one there, is all sides are equal. Every side is equal. And one way of showing that, they don't show you on this page, but one way that you often see of showing that is they'll just put little slash marks. And if all the slash marks are the same, that means they're all equal to the same. So if I see one little slash mark on each side, they're all the same side. Now, next is isosceles. Isosceles. Say it with me. Isosceles. That's the kind where two sides are equal. So I would see a slash mark here, a slash mark here because those are the same. And then I would see two little slash marks here because that side is different. The last way is scalene. 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 no sides are equal. So you might have a slash mark here, you might have 2 on this one, and then 3 on this one. The slash marks in no way tell you how long they are. It just lets you know, it's a quick sign to show you that they're all different, that none of them are the same. So if you use that knowledge to look at 5 through 8, all they want you to do, they don't want you to do anything with the numbers except tell them what kind of triangle it is. So on number 5, where you've got the blue triangle, one side is 6, the other is 5, the other is 4. They're all different. That's going to be scaling. That's all you're going to write there is scaling. On the yellow one, 10, 10, and 5. 2 are the same. One's different. Did you say it right? Isosceles. Good. Spell it correctly, too. You've got it right in front of you. Let's read 9 and 10 together. Can an isosceles, that's here, can an isosceles triangle have side lengths of 8, 9, and 10? Nope. Why not? In an isosceles triangle, 2 sides have to be the same. So it could be 8, 8, and 10, 9, 9, and 10, 9, and 10, 10. But it can't be 8, 9, and 10. What about 10? If the measure of an angle in an equilateral triangle is 60 degrees, what is the measure of the other 2 angles? Well, look at number 2. 60, 60. What was the other one? 60. So the other 2 are going to be 60. Now, at the back, you should be able to do 11 through 13 based on what we've talked about already. You look at the triangle that each one of those people made, and you tell me, you label the triangle according to what their sides were. 14, 15, 16, you should be fine. Look at 17. Perpendicular lines are this, like a cross. Perpendicular lines form blank angles. What do they form? Right angles. They form right angles. Okay, I wanted to look at this chart with you. Let me see if I can make my chart just a little bit smaller so that it'll fit there. Okay, well, come on. Okay. Identify the pair of congruent triangles by their angles and sides. So they want you to label them both ways. So if I look at this, this is A, and it was a rectangle, and it was sliced right down the middle diagonally. According to the angles, well, we see this corner right here. So according to the angles, it's going to be a right triangle. According to the sides, all of those sides are going to be different. This one is going to be longer than this, and this is shorter. So if they're all different, that is going to be scaling. Look at this one. All of those angles, there's not one right angle, is there? There's not one obtuse. That means they're all cute. And then because that was a square tilted to the side, which makes a rhombus, all the sides are equal, so all of those are going to be the same. That's going to be an equilateral, which won't fit on my chart. Oh well. You know what to do, right? Got it all on the screen now. Yay, that helped. Good. There we go. You just have to be patient with me. I'll figure it out eventually. Okay, and then C is this one, which was a square. This is going to be a right angle. Again, we see the right angle there in the corner. And then that one is going to wind up being an isosceles. Can I spell it right? Isosceles. These two are going to be the same, but this one's going to be different. All right, 21 and 22, you are drawing based on what they tell you. So if all sides are equal lengths, but there are no right angles, that leaves you with what shape? It cannot be a square, but if they're all the same, see if I can make one. If they're all the same, but there's no right angles, then that's what you're going to have. And what is that? Let's label it. That is called a rhombus. Now look at 22. Opposite sides are parallel. Okay, so all the sides are going to be parallel to each other. They're not going to be going in weird ways. Opposite sides are equal lengths, and opposite angles are equal. So, what about a square? Opposite sides are parallel, they're equal lengths, and the opposite angles are equal lengths. What about, whoops, that's just a bigger square. What about this? What about a rectangle? Opposite sides are parallel. Opposite sides are equal lengths. These are equal, and opposite angles are equal. Yep. It would even work for a parallelogram, which is similar to what we have over here. So you might have something that looks like this, like the shape of Tennessee. All right, lastly on the bottom there, find the measure of the unknown angle. So 23, box, box, box. Should there be a box here? Yes. What does that mean? It's going to be, you got it, 90 degrees. 24, box means 90 plus 50 equals 140. 180 minus 140 is 40. Missing angle. Bingo. Last. Look at this. 110, 110, 70, guess what? 70. Opposite angles are going to be equal if your sides are equal, if they're parallel and equal. So 110, 110, 70, 70. You got it. Have a great day.